So again, I'm Brock Palen from the University of Michigan from Advanced Research Computing Technology Services. Real quick overview of the University of Michigan. We're actually the largest public research institution by research spend at about $1.5 billion. That is both fortunately and unfortunately spread across over 100 top 10 graduate programs, and there's many other programs beyond that. This introduces both an opportunity for a lot of multidisciplinary science activities, but it also makes supporting what is being done on our different systems on our campus very difficult, because we have needs everything from high energy physics, life sciences, medical, protected data, unprotected data, things like that. Who am I? I'm a nuclear engineer who never got a job in nuclear engineering. That solar car there is actually important. If you don't know, Michigan has over half the national championships for solar car. And I was working on it as an undergrad, and my parents told me I needed a job if I wanted to stay in school over summer. I got jobs pulling cables at the HPC center, and I never left. So that's how I got into this field. So I've been doing this for a very long time. So who is ArcTS? I mentioned earlier in the panel, we're one of 4 groups under the Office of Advanced Research Computing. We've got the 2 faculty-led institutes, the Computational Institute, the Data Science Institute. They have graduate programs, degree programs, certificate programs. So if you want a certificate in computational modeling and physics or engineering, that's ran through there. This is our group. We're the muscle, right? We've got all the big systems, the big networks, and the contracts with the cloud providers. And then there's a consulting group too. That's where all of our data scientists and algorithms people and stuff live. So what are our challenges when building storage offerings? Traditionally, we've built a one-size-fits-all type system. So we told, it's like, I don't care what type of data you have, you're going to pay what it costs for us to build this system, and it's going to fit your needs. Truth is, there's a lot of different types of data out there. So, not the value of all data are the same. In the past, we did allow people to choose how much they valued being able to get their data back in a disaster. That is, you could choose whether you wanted replication or not. But we also did not differentiate between data that needs extreme performance, data that is archive quality, and other things like that. So that really what we saw on our campus was a lot of build your own storage. So what else do we have going on? Well, we have thousands of users. They tend to be novice level. They're master's students, first year PhD students. We don't run leadership class problems. We run an awful lot of serial work on our HPC systems and our big data systems and stuff like that. Well, big data inherently is not serial, but you get the point, right? Very wide user base, very diverse scientifically, needs are vast. So what are some examples of things we do? We have a couple of autonomous shuttle buses and a complete autonomous vehicle test track. We have a 5G test bed deployed there, in which we're testing, collecting data from all these different vehicles. We've instrumented our entire city. Stop by our booth and test your knowledge against our algorithm for detecting whether or not news is real or fake, completely made up stuff. And then this is actually an example. So this is Alberto Figueroa's work. This is one of those systems where combining machine learning and traditional modeling. This is an FSI problem that went into a real patient. That's a phantom model up there. That's not actually a patient's data up there, but this algorithm is used regularly for making custom stents for going to patients that have deformities in their cardiovascular vasculature in their heart, where traditional stent methods, would normally, as Alberto likes to tell me, bust right through the side of the vessel wall as soon as we restart the heart. So this is real stuff going into real people, making real impact. So this is just a drop in the diversity of what we have. So what did we find when we started looking at providing different storage offerings? This is a little bit weird to look at here, but what this shows basically is on our old Scratch file system, 99.6% of our files were 1 megabyte or less, and it consumed only 4% of the space. 99% of the metadata represented data that only consumed 4% of the space. Why did we start looking at this? There was a very nice paper that came out of San Diego a couple of years ago, and we started looking at options. And I'm going to go down a slightly different path here in terms of something that we did with DDN. We've pretty much focused most things here with DDN about performance. Well, it turns out there's a lot of different interesting things you can do with the SFA architecture. Like, if you don't care about performance, you can get the price really, really low, right? If you have kind of near-line data, stuff where you want reasonable bandwidth, but you throw out assumptions like, I'm not going to have files less than a megabyte on there. I'm only going to put my big imaging, my big omics, my big climate, the data that consumes the majority of the volume of the stuff. And to do that, we built a system jointly with DDN called Locker. This is just a simple grid scaler, 14K embedded. We're using protocol nodes for accessing the data. We're not using GPFS native clients. It's something we're going to test in the future on a new cluster going in, where we have a 14K E, but with IME running natively, because that's designed for performance. This was designed for capacity at the lowest dollar possible. This has no flash for metadata. This is all nearline SAS drives, and it's really, really inexpensive. And you know what? We just turned it on for regular users a couple of weeks ago, and we already have 2.5 petabytes on the system. We bought 5. yeah, he's looking for the PO over here, right? And so we have 2 of these. We have it set up so we have synchronous replication between the 2. You can optionally choose between it. We've also done some work with another party to be able to provide deep archive on magnetic media. But this is working really, really well. And we're actually getting good bandwidth out of it. You can actually get really good bandwidth if you don't let users put those 99% of small files on there. So we took that 4% of data and said, here, go over here to this different solution. This is where 80% of the data is going to end up. And we're already seeing that happening. Because what was happening before, we would build this one-size-fits-all solution that would work really well for a lot of metadata. The price would be relatively high. Again, we charge our faculty for using storage. And then they're basically look me in the eye and say like, well, that's crazy. CDW will sell me this. And all of a sudden, I've got storage in the basement. And then a couple of years later, I've got someone coming to me and like, my student who operated this left, and I just got an email, and I don't know what it means, and it's too late. You already lost data. This is a real thing that happens on campuses. And what's completely crazy about that is they replaced that failed system with the exact same thing. Why? Because when we built those one-size-fits-all enterprise solutions, which was a traditional enterprise storage vendor, kind of marketed at your SAN environments and things like that, the price differential was too high. This is getting down to a point where it's very, very acceptable to people. And not only that, we encrypted the whole thing. This is using self-encrypting drives. The SFA architecture, being able to have a minimal amount of extraneous additional equipment besides spindles, really, really lets you get the price down well. So DDN's more than a one-trick pony. You can get really fast stuff, or they can engineer you something that works really, really well for people who just need capacity at modest performance. And so how do we have people migrate data back and forth? We're big Globus fans, and we just set up asynchronous transfers, stage stuff out of Locker into Scratch, do your work. Scratch is designed to be fast, but it's a more expensive system. We don't want you leaving anything there, but this is still active data. And we export this out to laboratories. So we've got these mounted on sequencers, nano CT. This is a photo here of our autonomous vehicle test track. They're collecting massive amounts of video. They're all large files. They actually fit the environment really, really well. So don't make a one-size-fits-all solution. Now, you might ask, why did we not just do tiering? Why don't we still do one-size-fits-all, but then in software let people choose? Very large user base, it's kind of hard to explain why they're getting different performance and stuff besides just having a different product. So it's something we'll probably look at in the future when we look at refreshing our traditional NAS. But right now, this is working really well. A lot of people that we've talked to for years that were building their own storage solutions that use us for compute all they want, but they wouldn't use us for storage. We were finally able to get down to a price point that they were comfortable with. So this is really working out well for us. And the hospital loves us for it, because they're completely paranoid about anybody using patient data and sticking out anything that's not encrypted, not monitored, not audited. So basically we have a 3-tier, well, really a 4-tier storage. We have tier 0, Scratch, no replication, designed for extreme performance. That's where we have IME, data on metadata, grid scaler. Then we have general purpose NAS. It'll eat anything, but it's kind of expensive. Bulk data NAS. This is where most of our data volume in the future we expect to be, but only a subset of our users. So we're basically, taking care of our whales, those with the largest data volumes for active data, and taking care of their needs. And then we have, the deep archive. So this is the classic thing. People are probably wondering. This is our IME setup that we have going in right now. This is just a graphic I stole straight off of DDN's website. I just cropped it. But we chose to put about 5% of our data on IME for the new Scratch system based on measurements from our old Exascaler, which is a Exascaler 10K based system that DDN support's telling me I need to put a bullet in as soon as possible because of parts availability and support. And don't worry, I'll do it. As soon as you get this thing turned on, I'll turn your other one off. But we're also, we still have flash metadata, data in metadata for GridScaler. So we've basically got flash through the whole system, but it's a more costly system. But it's extreme performance, InfiniBand connected. The other system's all IP connected. So our new cluster, I'd like to thank DDN, Dell, and the other partners involved with that for that new system to make that happen. But really, I want to focus back, stepping up back a little bit for providing this persistent storage solution to be able to provide the locker storage that we call it, which is, again, that 14K designed for extreme cost availability. Because here's the way storage works in the academic environment. I have a fixed budget, and I have an unlimited appetite for data. So I'm not actually changing the amount of money that the faculty are spending. I'm changing the amount of opportunity they have to be able to hold on to more data. So no money is left on the table here for anybody. Just more opportunity is created when we're able to store more. Because more and more things, you've talked to high energy physicists, they're worried that they're not going to be able to have funding, they're going to be 10x, 20x short on the amount of capacity you're going to be able to have to hold data. So anything we can do to better serve our faculty to be able to hold data is definitely a good service to provide. And so again, I'm very grateful to the crazy engineering and the DDN team listening to my ranting and raving about what we actually need, because faculty are already voting with their dollars. Oh man, no, he left. Oh no, he's over there. My DDN sales guy, wave to everybody. What do I tell you? Our largest storage vendor on our campus is Drobo. No, seriously. When faculty can spend their own money, Drobo is the largest storage vendor on your campus. And so you got to meet them halfway. And we were able to do that, and we're very excited with how quickly the amount of data going on. 3 years ago, we didn't have a storage service. Now across everything we've got, we're holding on to 14 petabytes of data, and it's growing at an absolutely massive rate. So again, thank you very much.